The goal for today's mini lesson is for you to be able to graph linear equations. So to do that, we're going to start by identifying and reminding you of a couple key pieces of information. So remember, this is our template form of any linear relationship where we've got y equals mx plus b, and m, remember, is going to represent our slope, which is our rise over our run, and our b is our y-intercept. And so what that might look like, let's say I've got a line, I don't know, it looks something like maybe we'll make it go through like this. We'll draw it like, about like that. Great. Okay, so let's say I have a line like this. It looks like my x-intercept is right here, and x-intercept is where it crosses the line, crosses the x-axis, and so this point right here would be at -6, 0. And my y-intercept, it looks like it comes here. Let's say if this is 6, that's 7, maybe that's 7.5. This would be our y-intercept, where the line crosses the y-axis. And so what's important about both x and y-intercepts is you'll notice that they always have one coordinate that is 0. So in an x-intercept, it's going to be the x comma y is 0. And in a y-intercept, well, I'm not going to move over at all in my x, and so it's going to be 0, comma, whatever that y-intercept is. So for the sake of this, let's call that one 7.5. So every y-intercept will have an x-coordinate of 0. And why that's helpful is that if we're looking at a table, for example, I know that right here, I would say, okay, this one, my x-coordinate is 0. Whatever the corresponding y value is, I can put that number right here. And so if I was filling out this table for this one, I would say, oh, this y value here is 7.5. So again, x-intercept where the line crosses the x-axis, y-intercept where it crosses the y-axis. Every y-intercept will always have an x-coordinate of 0, and every x-intercept will have an x or y-coordinate of 0. We're going to press pause on x-intercepts for now. You'll learn more about those in future math courses. For now, I want us to focus in on this y-intercept because it shows up in this template form. So in this template form, this b, whatever this number is right here, that's your y-intercept. So let's say I'm given an equation, maybe the equation of y equals, let's do -2x plus 3. So if I wanted to go graph this equation, essentially what I can start with is, well, I know that this is my y-intercept because this is that b. And so I might start by simply identifying from slope-intercept form, this guy, the b value. And since I know that every y-intercept has a x-coordinate of 0, I can just simply come over 0 and up to 3. And that's where that point on that graph will be, is right there. And so I like to plot that y-intercept first, and then I can use my slope to essentially rise and run from there. And so remember, essentially slope, since it's rise over run, I could rewrite this as, I'll do my colors here, -2. Well, it's not a fraction yet, but if I wanted to turn this into a fraction, well, I can turn any fraction into, or any whole number into a fraction by simply placing it over 1. And the reason I like doing this for graphing linear equations is because this essentially says, hey, I need to rise 2 in my x and run 1. And since this happens to be, this is a negative, that means I'm going to go down in my y as I go positive in my x. And so what that might look like, if I'm starting here at this point here, I need to go down -2, so I'm going to go 1, 2 this way, and then I'm going to run +1 this way. And as you get better at graphing, you don't actually need to draw these arrows in, but that next point on my linear relationship will be right there. Again, I'm going to go down -2, oops, that is my wrong color, down -2, and run 1 in my positive direction. And my next point would be right here. I'm going to go down -2. Oh, wait, did I do that right? Oh, I graphed that in the wrong spot. Good Lord. That's why I like those arrows. Helps you figure out, oh, yeah, it should have been right there. Okay, so now I need to come down -2 and run 1 positive. Oh, good Lord, I've graphed this whole thing backwards. Good Lord, Miss Hall. Okay, so I just did the classic mistake. I went down 2 over 2. So Again, part of the reason I like those arrows is it helped me figure that out. This slope, goodness gracious, says down -2 and run +1. So let's actually label these. I'm going to do it. Oh my goodness. All kinds of mistakes are being made right now. Mistakes are good. Okay, that says -2 down. Now I'm going to go +1 this way, which is only 2 right here. There it is. Okay, so now I need to come down -2 again. And now I'm going to go +1 this way. Goodness gracious. I need to go down -2 and +1 this way. And so again, I'm just putting in my bullet points of to where these next points on my graph would be. So down -2 and +1 this way. And so you can kind of start to see this stair-step ladder. I can also go in this direction of my graph as well, because remember this, it doesn't really matter where the negative symbol is. I could also rewrite this as 2 over -1. It doesn't matter where that negative symbol is. So if I wanted to go +2 in my rise and -1 this way, right? Well, I'm still going to maintain that same slope. So now I'm going +2 rising and -1 running, and I end up again on that same line. So important here is to maintain, since we know this is a linear relationship, all my points have to fall on the same line, and I want to double check with my slope as I'm rising and running, sort of drawing those points. Again, rising is in my change in my y, running is my change in my x. So I started here at my y-intercept, and I went into both directions. And then I can connect all these points, and then to indicate, hey, this linear relationship is going to go, oops, that's off a little bit, there we go. Linear relationship goes on forever. I'm going to put an arrow on either side of it. So use a tool, use a ruler to help you draw your graphs correctly. So that's one way I could go about graphing it, is if I had my equation, I started by identifying my y-intercept first, and then I used my slope, rise and run, double checking my slope so you don't make a mistake like I initially did. If I have a table, I can also simply plot those points. And so maybe if I was given, like, these were my initial points of like 3, 1, -1, -3, and let's call that -5. If I was given those points, essentially what that would mean is I was come over 0 and up 3, put a point. I would go over 1 and up 1 and put a point. I would go over 2 and, what is that? Over 2 and down 1 to get this point. Over 3 and down 3 to get this point. Over 4 and down 5 to get to this point. So if you're given a set of tables, values in a table, you can sort of plot the x, y. But you can also go back the other way. If I'm given a graph, I can identify key points and figure, okay, well, when x is 0, what's my corresponding y value? When my x is 1, what's my corresponding y value? So again, I can always identify my y-intercept because that's where my y is some number and my x is 0. So big takeaways here. The template format will always give you, in this y equals mx plus b formula, it gives you your y-intercept right here, and then the number that is in front of that x is your slope, and writing it in fraction form allows you to write that as rise over run. So if my equation had been y equals 1/4 x plus 7, I would have gone up here to +7, and then up 1 in my rise, and over 4, goodness, over 4 in my run. So it would look like up 1 and over 4, up 1 and over 4, up 1 and over 4, or down 1 and subtracting 4, down 1 in my y and -4 in my run that way. So this is my slope, and I can plot it using rise and run strategies. And then the last part would be to connect all of those points with a straight edge and an arrow on either side indicating that thing goes on forever.